Hi there, and welcome to Lesson 9 of Algebra 2 Remote Learning with Hotard. I'm broadcasting today next to my daughter's inflatable car, currently filled with stuffed animals. It's quite comfortable, really. No more comfortable place to do algebra, in fact. So today, I'll be hanging out the passenger side of my best friend's ride, trying to holler at you about multiplying and dividing rational expressions. Okay, now just a heads up, before we start any of the new content, I posted a 7.3 Practice A page on Moodle. The first 6 problems on that page are just a review of what we did last time, simplifying rational expressions and identifying the excluded values. So it'd be a good idea to right now just hit pause, try those first 6 problems. All right, just a heads up, one of them cannot be simplified. In case you get stuck on one of them, no, you didn't make a mistake. You cannot simplify it. But just try those out first, 1 through 6. Did you try? Did you check your answers on my answer key? I hope you did. So now, today, we're going to be multiplying and dividing these rational expressions, these fraction expressions with variables in them. Before we get into the algebra, let's just very quickly review multiplying fractions. 7 over 2 times 2/5. A lot of people think, oh, I need common denominator. No, you don't. You need that for add and subtracting. Multiplying fractions, you could just multiply straight across. 7 times 2 is 14. 2 times 5 is 10. So I get 14 over 10, which I can reduce. I can divide top and bottom by 2. And so my final answer is going to be 7/5. That's one way to do it, multiplying fractions. The other way, you could multiply first and then reduce like what we just did, or you could reduce first and then multiply what's left. A lot of times that's quicker. You could reduce up and down vertically. You could also reduce diagonally. I could say 2 and 2 cancel out, and so my answer is just going to be 7/5. All right, some people don't know that you could do that, but you can. You could reduce, you can cancel vertically and diagonally. You just can't cancel horizontally, side to side. So 7/5. Now, we're going to come back to number 2 here in a few minutes, but we're going to use this method, both the methods really, of multiplying fractions to work these algebra problems. So if you look at number 3, I'm multiplying these 2 fractions just like I did above. Now, I could do it either way. I could reduce first. I could say, hey, r squared and r squared cancel out. I can reduce 4/8 to 1/2 and then multiply what's left. A lot of people tell me when we're multiplying these monomial problems where there's no plus or minus, most people tell me they think it's easier to multiply first than reduce. So that's how I'm going to work these first 2 problems. So I'm going to multiply across. 4 times 10r squared is going to give me 40r squared. And then over 8r squared times 3r, 8 times 3 is 24, and then r squared times r. Remember, multiplying, you add the exponents. So that's going to be r cubed, r to the 3rd. So now I'm reducing what's left. 40 over 24, I can divide top and bottom by 8. So that's going to leave me with 5 over 3. And then for the variables, remember, when you divide, you do what with the exponents? You subtract them. That's going to be r to the 1, and it's going to go on bottom because that's where the bigger exponent is. 5 over 3r. That's my answer. And then as far as excluded values, what can r not equal? Remember, if it's a monomial problem, it's easy. What's the one number that if you plug it in will give you 0 on bottom? 0. R cannot equal 0. So we're going to do the same thing with number 4. Again, another monomial. Yes, I could reduce first if you want, but I'm just going to go across first and then work whatever's left because that's what most people tell me in the past that they thought was easier. So let's just multiply across. 7 times 6, 42. No? Yes? Okay. Coronavirus is getting to me. 42 m to the 4th over 8 times 6, 48. I have m squared and n to the what? To the 4th. All right, so now let's just reduce this. 42 over 48, going to leave me 7 over 8. Or I can divide top and bottom by 6. All right, and then m to the 4th divided by m squared, going to leave me m squared on top, and then I still have this n to the 4th on bottom. So there's my answer, nothing more I can do there. And then I just need to list my excluded values. M cannot equal 0, N cannot equal 0, again because it's monomials. If you plug those numbers in, you would get 0 on bottom. All right, this one it probably would have been easier first to just cancel out the 6's diagonally. All right, then you'd just be left with 7 over 8. Either way. All right, 2 more problems, then we're going to take a quick little practice break. Number 5. Now, these are not monomials. If it's not monomials, and that means if it has plus or minus, you're going to have to factor something. Don't try to cancel out yet. Start factoring first. So over here, up in the top, I need to find some numbers that multiply to give me negative 70 and add to give me negative 3. So it looks like 7 and 10 would work. Bigger number would have to be negative. So I could factor this into n minus 10 and n plus 7. Those would multiply to give me negative 70. They add to give me negative 3. Underneath that, nothing I can do with n minus 8. I can't factor that. Now, the other fraction, remember, what's the first thing you're supposed to look for when you factor it? Greatest common factor. GCF up here on top is 4. So that's going to leave me with n minus what? 8. And then on bottom, again, GCF is 4. Divide that out, that's going to leave me with n minus 10. Now, these type of problems you're definitely going to want to simplify first before you multiply out. Remember, I can reduce up and down. I can reduce diagonally. I just cannot reduce side to side. So I could say, hey, the 4's cancel out. I could say this n minus 8 and this n minus 8 cancel. I could say this n minus 10 and this n minus 10 cancel. So what's left in the problem? N plus 7. That is my answer. N plus 7. And then excluded values. N cannot equal, remember here, it's not just going to be 0 this time. You're looking in your work, what will give you a 0 on bottom in each part. So positive 8 minus 8 will give me 0. There's no variable on this, so that part doesn't matter. Positive 10 would give me 0. So that means n cannot equal positive 8 or positive 10. All right, let's look at one more problem. Number 6. All right. First of all, this 3m minus 3 is not a fraction. All right, if it's not a fraction, remember that's automatically over what? Over 1. And if there's nothing between them, it automatically means multiplying. So let's just rewrite this. I'm going to have 2 on top. The bottom, let's see, I'm going to have to factor this. Now, again, first step for factoring is what? Greatest common factor. So I know I can pull out a 3. So let's just write that up here. 3, and that's going to leave me with m squared plus 3m plus 2. Now, that's not done. I need to find numbers that multiply to give me 2 and add to give me 3. 2 and 1. So on bottom, I'm going to have 3 GCF, then m plus 2, m plus 1. A lot of people forget 1 times something gives you that number. You could always use that. Okay, and then second fraction, 3m plus 3. How do we factor that? Greatest common factor again. GCF is 3 there. That's going to leave me with m plus 1. And then just 1 on the bottom. So I factored everything. Do you see anything that could cancel? See m plus 1s and also the 3's. So I'm going to be left with just 2 on top and then m plus 2 times 1. That 1 doesn't really matter. So just m plus 2 on bottom. And then as far as excluded values, m cannot equal, again, look at your work. There's no variable in the 3. It doesn't matter. I cannot get negative 2 or negative 1. Those would give me 0 on the bottom. Remember, you cannot divide by 0. All right, so m cannot equal negative 2 or negative 1. So now, before we do the last 2 problems, that's multiplying, I want you to take a moment, pause your video, go ahead and try to answer questions 7 through 13 on the Practice A page. Check your answers on the key, and then come back and we'll finish the division problems. Did you do it? Sure you did. So now let's talk about dividing fractions. Go back up to number 2. All right, 7/8 divided by 4/8. Does anybody remember how you divide fractions? You may have heard the expression keep, change, flip. All right, you keep 7/8 the same, you turn it into a multiplication problem because dividing a fraction is the same thing as multiplying by the reciprocal, by the flip over. So 7/8 divided by 4/8 is really 7/8 times 8/4. All right, so I could multiply across, then reduce. Or in this problem, it's definitely easier to just reduce first, cancel the 8s, and say, hey, the answer's going to be 7/4. So remember, division problems, only dividing fractions, you need to flip the second fraction, and then you multiply. So let's apply that same rule to these last two examples. So number 7, 7a over 9 divided by 4a to the 4th over 3. Keep, change, flip. Let's just leave this as 7a over 9 times, this is an a right here, times the flip over, the reciprocal, 3 over 4a to the 4th. Now we could multiply across, then reduce. We could try to reduce first and then multiply. Either way, I'm going to multiply across first. 7a times 3, 21a over, now this is a 9, not an a. So 9 times 4a to the 4th, 9 times 4 is 36, a to the 4th. Now we just have to reduce this. So 21 over 36, let's see, we can definitely divide by 3. That's going to leave me with 7 over 12. And then the a's, remember that's a to the 1 right here. And subtract those exponents because we're dividing, going to leave me with a to the 3rd on bottom. 7 over 12, a to the 3rd. Now this time, when you list in excluded values, as things a cannot equal, all right, you need to look at the bottom of your work. But also, we flipped this fraction, so you also need to keep in mind the bottom of your original problem. Now, there are no variables on the bottom of the original problem. So in this case, I'm just looking at my work, and it's just a monomial right there. It means a cannot equal 0. So let's do one last example. Last one. All right. I need to factor this time because it's not just monomials. I need to try to factor everything that I can. And don't forget, since it's dividing, keep, change, flip. I'm going to flip the second fraction. So let's start with this. 10x minus 20, GCF. Greatest common factor is 10, so that's going to be 10 parentheses x minus 2 over 10, and I can already see that these 10s are going to cancel out. All right, then keep, change, flip. So I'm going to flip this. I need to factor each one of these, so I'm just going to factor this. I'm going to start with the one on bottom. X squared minus x minus 20, numbers that multiply to give me negative 20 and add to give me negative 1. That's negative 5, positive 4. X minus 5, x plus 4. Over, because I'm flipping it. So now the top one, numbers that multiply to give me positive 10, add to give me negative 7. It's going to be 5 and 2, both negative. So that's going to be x minus 5, x minus 2. See, I flipped this one, and I factored everything. So now, let's cancel a few more things. We already said 10s cancel. Remember, you can cancel diagonally or up and down. So x minus 2s will cancel. The x minus 5s cancel. What's the only thing left in the problem? X plus 4. So there's my answer. And then x cannot equal, I need to look everywhere now. So here, let's check my work. No variable here, so nothing there. On the bottom right here, x cannot equal 5 or 2. So x cannot be positive 5 or positive 2. But also, in the original problem, x squared minus x minus 20 was on bottom. This was on bottom. So I also need to look right here. X, we already said, cannot equal 5, but it also cannot equal negative 4. That would make the original problem undefined. All right, so really, you're looking everywhere in your work except for the top left. All right, it's okay if that part comes out to be 0, but everything else cannot be 0 as far as listing your excluded values. So go ahead and try the rest of your practice page. Check your answers on my key. Email me if you have any questions. All right, we have 2 weeks left until officially summer vacation. Y'all have a great 2 weeks.